Hi, I'm Justin Rubin.
And I'm Joey Salson.
We are giving a presentation on a lab we did for electronics instrumentation lab at Johns Hopkins University for 530.241. The goal of this project is to design an analog electronic feedback controller system that controls the velocity of a DC electric brush motor. Our project is broken down into three parts. We have a potentiometer control voltage source, we have the actual motor itself, and then we have a circuit of several LEDs that monitor the system. So part one, the potentiometer. The potentiometer receives its voltage source from a positive 18 volt source and a negative 18 volt source. From those, we then use a series of resistors and Zener diodes that feed into a potentiometer, which then regulates it down to plus or minus 2.5 volts max. So that potentiometer can then feed anywhere between negative 2.5 volts to positive 2.5 volts to the motor system.
From there we take the command voltage to an INA 111, an instrumentation op-amp. And so with that being the positive input and a negative input coming from the tachometer output, which we'll get to later, the instrumentation amplifier we set up with a unity gain by putting no resistors across it. And this gives us the difference between the tachometer and the input voltage.
From there, we then let our voltage through another gain of negative 3.567 to, after taking the difference of these two voltages, we then take this through another gain of negative 3.567. And then from there, it goes into an OPA 511, which is a voltage current amplifier, which has another gain of 1/2 amp per volt, which then that leads right into the motor. After the voltage to current amplifier, the system then feeds right into the motor and tachometer. The tachometer will spin the motor at 1000 RPM for every 0.52 volts going into it. So between our potentiometer feeds negative 2.5 to positive 2.5 volts, we could get anywhere between negative 5000 RPM to positive 5000 RPM on the motor itself. And after the motor is spinning through the tachometer, the voltage will then feed back into the INA 111 at the very beginning, which was monitored also with the potentiometer voltage. So that way the circuit knows if it's going into positive angular velocity or negative angular velocity. There are three systems monitoring the circuit. The first part is to determine whether or not the angular velocity on the motor is positive or negative. The second part is to determine whether or not the angular velocity is within 10% of our desired velocity. And the third part is to determine whether the current going through the motor is within 0.25 amps or greater.
For the next part of this circuit, we take the velocity out from the tachometer and we put it through a comparator, which we compare to ground. And based on this, we connect the collector output to a series of diodes with a diode gate to control whether a green light goes on if it is positive and a red light goes on if it's negative.
For part two of this, we are comparing the angular velocity of the motor compared to the angular velocity desired from the motor. And we want to determine whether or not this is within 10% of our desired velocity. So we took the voltage from this potentiometer, brought it down to 10% of that, sent it through an absolute value circuit, and then sent that to a comparator. And that was being compared to the difference between the voltage from the tachometer and the potentiometer being fed, and that was from the circuit itself in 9A111. If it was within 10%, what would happen is a green LED would light up. If it was greater than 10%, then a red LED would show up. For part three, to see whether or not we're within 0.25 amps of the desired current, we determined that the voltage through coming out of the OPA 511 needs to be 0.5 volts. So we compared this to an actual 0.5 volt source, which we created from an 18 volt source, and using several resistors brought down to 0.5 volts. The voltage from the OPA 511 was then set to an absolute value circuit and compared to our 0.5 volt source. And so a green LED would turn on if it was less than 0.25 amps, i.e. less than 0.5 volts from the tachometer, and it would be a red light if it was greater than 0.5 volts, i.e. greater than 0.25 amps coming out of the OPA 511.